Hello YouTube and fellow radio hams. This is a video about the CM108. I've done lots before, but in this one I'm going to go into a bit more detail. Often get asked questions about, so I just want to talk about this sound card which is used for the Allstar software. I get questions from repeater keepers saying I want to build an interface, how do you do it? So if I talk about the card a little bit, how the inputs and the outputs work, hopefully it'll give you a much better idea of how you can use the card. So just very briefly, we've got a USB interface on one side, we've got the CM108 chip in the middle, and on this side here we've got our audio out and audio in. Now these would have been soldered on 3.5mm sockets, and we'll just, by the power of video editing, we're just going to have a quick look at what that would have looked like initially. Right, okay, so the chip has a stereo output on this side, so output A and output B, or left and right, whichever way you want to do it. In Allstar it's referred to TXA and TXB, and those pins come out somewhere over here, and they're passed through two coupling capacitors here and here. So this over here would be TXB, which would be like the right channel in audio terms. Since Allstar is mono, we only need one channel, so that we can remove this capacitor because we don't need it. This pin here that says speaker out in Allstar software is TXA. Obviously the audio output is fairly low, it's designed to drive a little pair of earphones or something, but you can get, you know, around what I would describe as being line level, maybe around 600 millivolts peak to peak into about 1k load. So that gives you an idea, which should be about right for most stuff. It's certainly perfect if you're feeding it into the external auxiliary audio in on a Motorola mobile set or a tape base station, whatever. It's about the right level, so perfect. This pin over here is an input, and we'll have a look at the data sheet, and we can see from the data sheet this pin is actually a GPIO. It's an input pin only, and on the data sheet it's shown as volume down. So with these devices, some of them they come in a plastic shell with some volume up and volume down buttons. The Allstar software is written specifically to talk to this card and this card only, and that's how we can make use of those GPIO pins. This pin here, right on the end, very easy to solder to, is an input, and it is our carrier sense, our COS input. So this is a signal from the receiver to say that there is a valid signal on the channel. So valid in the case of over the squelch threshold, and ideally with the correct CTCSS tone to save it opening up with just noise. These inputs and outputs, by the way, are 3.3 volts, so be very careful when you're connecting it to external hardware. What I would suggest here with this is to have a diode here. The idea of this diode would be to block any voltage going back in this direction here. This would block any voltage flowing back in, and the idea is you would pull that pin down to ground. It's got a very weak pull-up resistor, so it's pulled up to 3.3 volts. If you were connecting this to a receiver, you would probably want this output of the receiver to go to ground when it's got a signal present, or you'd have to use a little transistor and invert the logic to do that. So this is an input, and it's hard-coded to be the COS, carrier operated switch, COR, carrier operated relay, whatever you want to call it. It's basically an indication that there is a signal on the receiver. You would either take that from your controller or your receiver or CTCSS board. That's an input to tell Allstar there's a signal on the receiver. So on this example here, I've removed the capacitor here because we don't need it. That's the right hand audio channel. We come off here onto this pad here, and that allows us to use all this track here, this pad in the middle, this bit of track here, and that pad there are all connected to here. If you want to, you can drill out a little notch here, and that pad then becomes free. Okay, just to go back over here, this is an output, and this is our TX audio. In the Allstar software, it's actually TXA, and TXB is the other channel, but we're not using that, so we don't need to worry about that. Okay, right, moving on to the other side here, we've got another GPIO pin here, and this is an output, this pin, and it's the pin on the end, so again it's easy to get to, and this pin is hard-coded in the Allstar software to be the PTT, and that is the PTT output. In the Allstar software, you can configure this pin to either go high or go low, and when it goes high, it goes 3.3 volts high. You could then connect that to a transistor, but that is an output pin, and what I've done again is I've brought the wire around here onto this pad here, which has just got a little jumper in between there of track, and these two pins here and here are connected together. So I've notched out here, so we've now got these two are just connected together, and it means we can solder onto this pin here, and we can come away with a wire and it won't pull off this or doesn't move anything around. In another video you'll see that what I've actually done is I've used all of these pads here, and I've soldered a SOT23 NPN transistor across here. So the collector goes at the top here, the base it goes onto here. I put a 10k or a 1k resistor, the value's not overly critical, so notch out here, put a 1k here onto the base. Your emitter goes down here down to ground, and then you've got a nice open collector output. This goes active high, turns the transistor on, which pulls the collector down to ground, and then you can use that to output to your base station transmitter or whatever you're connecting it to switch on the transmitter. Okay, and finally, just down here we've got there's a couple of resistors that I've removed, and these resistors, and we'll look at this on the data sheet, these resistors are for the bias supply to provide a little bit of DC voltage to power an electret condenser mic that would have been plugged into here. So you can remove both of these resistors. On the data sheet it's shown as V bias, and we don't want a DC supply. The audio input is AC coupled via this capacitor here. The audio input on these is a high impedance, and it's expecting a very small signal, so there's lots and lots of gain on the input here because it's expecting a little electret condenser mic. So we need to attenuate the input of the signal, and the way that this is done is with a 1k resistor here to ground this. So this is this track here is the audio input labeled mic here, and all this track here to the end, this end here is ground, by the way. So we've got a 1k resistor here, and what this does is attenuates the signal. And normally if you're expecting a line level sort of type of signal here, you put a 20k resistor here, feed your audio signal from your receiver into here, 20k or a 10k. You'll have to experiment with the different values of what you need, but that will be your audio input, and that should be about right. Again, this is based on my own experience with a Motorola type radios and base stations using their GPIO socket, the audio input output levels from those. If you use this value here, you should have exactly the right level of signal going in. In the Allstar software there is actually a menu, text-based menu, where you can set the receive and transmit audio levels, so you can trim those from a value of 0 through to 999, so you've got quite a lot of adjustment there. There is also a visual indication on the screen of the amplitude of the signal, and that allows you to adjust this input, whether you use fixed value components or whether you use a trimmer pot to get the level. Just so, what I would highly recommend, and a lot of people don't follow this advice, but please use all of the dynamic range on the input of this chip. So ideally your RX level in the Allstar software, RX level should be 999, and then externally RX level 999. So you use all the dynamic range and externally attenuate the signal going in. What a lot of people do is they have their RX level at say 100, feed a massive signal into here, and then you hit the rails on the input to the ADC and it distorts and it sounds terrible. And they'll go, oh no, my RX level's fine, I'm not going off the end, but actually it's further down the chain on the input to the chip because it can only handle a very small voltage on that input. So there you go, that's the CM108. I think I've gone over all of the points that most people ask. So just to summarise again, our COS on this side indicates the signal on a receiver. It's a 3.3 volt input, so it must be protected with some kind of barrier diode or some transistor buffer. This is our PTT output. It goes active high 3 volts, although you can change that in the software, so you can flip the logic. Likewise, you can do that with the COS as well. You can either have it active high or active low. There is an internal pull-up in here, but it's very weak, so don't load this down too much if you're leaving it floating. And what else? We can use these pads here. Just look at the track, notch out the bits you don't want. Look on the other side of the board, and you can see there's some vias here around here as well. So you can see that this is connected to this via the back of the board. And make use of these pads. You can solder on some surface mount components. These are 1206, the size of these, so they're slightly bigger ones and they're much easier to work with. There's enough space here to put a SOT23 transistor, and you can put your 1K, your base supply here, notch out here of course, and that all works perfectly. You can put a 20K here and solder onto the end of a surface mount chip, and you can get everything on this little board. Perfect. So there you go. I hope you've enjoyed watching, and I hope this video answers all the questions, and thanks for watching. Bye bye.